Okay, hello everyone, this is Teacher Haji again. Today we're going to talk something new in science again. Okay, we're going to share my screen. All right, so that is what we're going to talk for today. Sorry for my pronunciation, we are Filipino. All right, tools in scientific investigations. That's what we're going to talk for today's lesson. Right, this is our objective. We need to describe the different types of scientific investigations. Right. Let's define what is scientific investigation. Okay, so we have here it is a scientist's efficient approach to research and answer a problem implementing the scientific method. That is scientific investigation. Scientists use multiple research methods to study the natural world. And there are three types of scientific investigations. We have number one, descriptive, number two, comparative, and number three, experimental. Okay. For descriptive, this is used when you are studying an object or situation for the first time. It primarily observes, describes, and measures different parts of the system. Observations derived from this type can be qualitative or quantitative and represented as diagrams. This type of investigation does not ask too many questions. That's for descriptive investigation. Example, we have here melting of ice cubes. The descriptive investigation may be used to identify and describe the temperature of ice, the shape of ice, whether it's tube, cube, or block, or how fast does an ice melt on a summer day. Okay, number two, we have comparative investigation. Okay, when you say comparative investigation, this shows a relationship between two or more seemingly related subjects or conditions. It involves collecting data on different subjects or different conditions, such as time, temperature, location, and evaluating them based on similarities and differences. For example, you want to know which will melt faster, ice with salt or without salt. You can easily set up an experiment to measure the time in which the ice with salt and the ice without salt will melt, and then the time it takes to melt both ice cubes may be compared to know which melts faster. Okay, that's the example. And then for number three, experimental investigation. When you say experimental investigation, this is used when scientists want to learn more about a subject. It is mostly used to determine the effects of changing a certain variable. Variables are manipulated, controlled, and measured using the scientific method, which we learned last meeting. Okay, example, you want to know if the length of the string affects the time it takes a pendulum to complete a full swing. You can design your experimental investigation based on the scientific method. Okay, we've learned the steps, the process in scientific method. We have number one, observation. A shorter pendulum, 15.0 centimeters, seems to swing faster than a longer pendulum, 25.0 centimeter. And for number two, statement of the problem. How does the length of the string affect the time it takes for a pendulum to complete a full swing? Okay, and then test three, collect preliminary data. The time it takes for a pendulum to complete a full swing is called a period. Mechanical energy is conserved in a pendulum motion. And then fourth, hypothesis. As the length of the string increases, the period also increases. And the next experiment, the length of the string can be varied and its effect can be checked by measuring the period. The length of the string is the independent variable, while the period is the dependent variable. And then number six, collect and analyze data. Record observations and present them in a table. A line graph can be constructed to show how the period increases with the length of the string. And then the last one, conclusion. The length of the string is directly proportional to the period. So that is an example of an experimental investigation. Okay, so that's all for our topic today. I hope you learn again. Please study your downloaded guide. You can Google the topic for a variety of resources. Bye.